Modern retrieval benchmarks are hitting a wall. Metrics like NDCG at 10 are saturating, making it look like information retrieval is solved. But a new MIT paper proves that's an illusion. They introduce OBLIQ-Bench, and it exposes a massive blind spot in how we evaluate search systems. The researchers identify a class of queries they call oblique. These aren't simple keyword matches. They're searches for latent patterns, like finding tweets that implicitly mock a geopolitical event, conversations where an AI silently violates a formatting rule, or math problems that share the exact same proof strategy despite completely different topics. The core finding is what they call the retrieval-verification asymmetry. When you feed a reasoning LLM a pool of documents, it can easily recognize which ones are relevant. But state-of-the-art retrievers fail to surface them in the first place. To prove this, the team built OBLIQ-Bench using a novel construction pipeline. They start with a human-defined lens for a long-tail corpus, run a reasoning model to annotate latent attributes in a single pass, cluster those annotations, and generate abstract queries that deliberately avoid source vocabulary. They tested 5 tasks across descriptive, analog, and tip-of-the-tongue retrieval. The results were stark. BM25, dense embeddings like Gemini 2 and QN3, late interaction models like latent, and even GPT-5-2 multi-hop agents all scored near 0. Why? Because obliqueness breaks the assumption that relevance can be approximated through lexical overlap, vector similarity, or iterative query rewriting. The signal is distributed, implicit, or cross-domain. However, when they applied a tournament-style listwise reranker with GPT-5-2 over a large candidate pool, recall and NDCG jumped dramatically. The relevance signal was there all along, it just wasn't accessible to first-stage retrieval. OBLIQ-Bench proves that the next frontier isn't bigger embeddings or more agentic hops. It's architectures that can natively capture latent, implicit patterns at search time. The paper and dataset are live, so go test your models against the new ceiling.